to the cloud. Okay, so let me introduce myself first. My name is Jeff Goldstein. I'm the Center Director for the National Center for Earth and Space Science Education. We are a 501c3 nonprofit. And hang on a second, there's something that just popped up on my screen. And we oversee large-scale STEM education initiatives that are meant to inspire and engage the next generation of scientists and engineers. One of them is called the Student Spaceflight Experiments Program, which is what we're talking about today. And in particular, we are engaged in Mission 21 to the International Space Station. That's the SSEP mission that you are all participating in. And so today, what I want to do is provide you a good, solid overview of educational philosophy of approach, because I want to make sure that you all understand how we're doing, how we're approaching this program. A good overview of SSEP. We're going to go through the timeline and how this is typically implemented at the undergraduate level. Then we're going to go into classic experiment design, microgravity experiment design, and we're then going to look at how students can think about what kind of microgravity experiment they can come up with, and we'll end with the navigation of the website where all the resources are that you're going to need. So does everybody kind of understand that, that outline? Cool. All right, the other thing too is, let me ask a foundational question here. How many of you have any background in microgravity experiment design? Raise your hands high. Doesn't look like anybody, which is fine. Which means that I'm going to tell you about a cool program that you're participating in, but then it's going to be about facilitating microgravity experiment design across your student teams. And that can be sort of like a formidable statement. It's like, I don't even know what microgravity means. So one of the things I'm going to do is really demystify that so you get to understand very, very concretely what a microgravity experiment is. It's actually very simple, and it grows from classic experiment design with a trick. And so we're going to go through classic experiment design carefully to just get everybody on the same foundational page with regard to experiment design processes in general, and then we'll switch over to microgravity experiment design. So all good? And just to respond, kind of give me a thumbs up. Okay, let me say one other thing that's important here. There are going to be sections early on at the end where I'm sort of like in lecture mode, because I'm just passing you lots of information about the program that you don't know. But when we talk about experiment design, I'm going to model best teaching practices. And what that means is that if you're in front of a class and you are teaching that class something, the best thing that you can do is engage your class with leading questions where you're asking them what they think. And the reason that that's important is, first of all, it forces them to think. Secondly, it allows them to have a sense of ownership in what you're trying to accomplish there in that classroom. And the end result is that when you kind of finish the story that you're trying to tell, the class realizes that they provided a lot of the information in that story. So it's sort of like a team approach to learning. And so I'm going to be modeling best teaching practices when we get to the experiment design section, which means that unless you have background noise, all of your microphones will be off mute. And I'm going to be asking lots of leading questions. There's no wrong answer. And I want people to just respond whatever is top of mind, okay? Just because we have to keep this moving, okay? So does everybody understand how we're going to play that game a little later?